As a starting visual, this is an idealized version of a BIM model constructed by the class and experienced together in VR space with students as avatars enjoying precarious and hopefully engaging views of the model and able to explore the details strongly connected to that spatial experience. I imagine our learning experiences might be like this, but we're not there quite yet. Briefly, let us explore a few issues in this presentation to stimulate discussion. VR has many facets and components to learning, so we should not just focus on the idea it's just about remote learning, even for this discussion. VR offers a realm of opportunities in the educational process. Accessibility and cost are significant issues because there are students and institutions with financial limitations. This lack of access can really impact the ability to realize some of these ideas currently. For now, let us imagine we can address this accessibility issue with low-cost solutions and free software. More about this towards the end. Now, let's start by thinking about course integration. A course development concept that I've found success with is to work within the BIM environment as much as practical, so students have access to all of the resources of analysis and other kinds of software tools needed to competently design projects. On that basis, it follows to identify VR technologies that can be a component of BIM. It follows then that VR can be a participant through the whole process, just as BIM. VR can inform the process from sketching a massing model to detailing, utilizing all of our tools and not exclusive of any. Setting up workspaces to accommodate that kind of workflow can be important to successful integration. Here we have a monitor with Revit running and another Enscape with VR active. Important is the idea of a dedicated personal VR headset. Currently, this one is $400. Placed on a shelf below the workspace, available to grab at any time to view the project or idea in virtual space for the stimulation of that immersive experience. For anyone thinking about classroom VR, one of the early branches of our decision tree is whether it's single or multi-user type of experience. For remote learning, being in the same virtual place at the same time may be critical. Great software is currently available and free to educational users for the single user experience. With Enscape, you click a button and you have active VR headset that you can put on immediately. While limited currently to a single user, it doesn't completely eliminate other viewers. Groups can experience the Revit model, but they won't be able to see it together, and that's a real significant detractor for learning and collaboration. Ideally, a remote instruction goal is a multi-user experience, and there are people doing that. The Wild and Resolve are products at various levels of development and offer collaborative multiplayer spaces where everyone can look at the same thing at the same time. The issue from an educational standpoint is accessibility. Currently, educational versions are not available and some don't have access without invitation. In preparation to incorporate VR in future coursework, I've done a little experimentation with VR experience and its potential to enhance spatial learning. Potentially one of the most important things that can benefit the student is the ability to bring them into the actual scale of architecture in a way that's really difficult to do any other way. To describe this without the VR experience, think about the visual loss of scale. This photo is a manipulation that's done quite a bit and alters our sense of scale. We can do that in a virtual space also with some software. In this example, Prospect is one of those that allows us to scale our model down. The effect of scaling the model down in the VR world is that you actually feel like the model is physically smaller, even though you really haven't changed anything relative to another component. This phenomenon needs to be experienced in VR to really be completely understood. Researchers are also exploring this idea of scale and looking for ways to better quantify the metrics in the experience. Users can experiment with the effects by adjusting the interpupillary distance to affect scale. I've experimented, but the overall sense of architectural scale is really well captured, almost with out-of-the-box settings. So keep in mind that there are exciting opportunities for students to understand space in a way that's just not provided in two-dimensional representation. In addition to scale, spatial immersion is another component of significant educational value. This is a typical way students create an image of their building for rendering. Usually they'll try and capture the whole building, so they'll look up with the camera and distort the relationship of the imaging plane so they'll get converging lines. In virtual reality, this doesn't happen. It's impossible for it to happen. So students experience their architecture in a much more natural, realistic way, key to a mature spatial understanding. When we can really move into VR space and provide enough software and hardware accessibility to our students, there will emerge new possibilities for experiencing our projects together. In a common space, walking through them in a virtual way, where we're really experiencing our architectural ideas in a more visceral, intimate way. One way to make that happen is to start working with game developers and using the tools and power of their software engines for rendering multi-user experiencing and working on different platforms. This demonstration video illustrates one such company doing that, Unreal, and how complex it is currently. Unity Software is also experimenting and developing AEC products. These are all hyperlinks, so you can go ahead and check them out. This is an idealized model from a video and diagrams a hosted model. In this example, two people in remote locations are virtually manipulating common objects in space. These could easily be architectural objects, with both having input and control over it with the feedback from the shared model. Cooper Union's visual student presentation this year is a great look at the trajectory of VR. It's built on a gaming engine and quite advanced, with all the students' projects in a virtual space that you can move through. All of this may seem a bit intimidating and cost prohibitive at first. It's easy to start small, using a smartphone and Google Cardboard, and sharing a QR code to examine a panoramic view. Students usually adopt and advance ideas quickly, and may be a partner in advancing integration into the classroom. Thank you.